Good evening and welcome to the Spring College of Business Distinguished Speaker event. For those of you who are here for the first time, welcome. I hope you enjoy being here in our Chan Auditorium. For those of you who have attended our events in past semesters, welcome back. We are packed tonight, as you can see. Climate change is one of the most talked about subjects in the mainstream media, but increasingly, the rhetoric is about choosing sides rather than about understanding a complex issue. For business and government leaders who must make real decisions about the future, in spite of the uncertainty, it is important to separate facts from politics. For all of us, it is important to open our minds to information that might challenge our own preconceptions, no matter what those preconceptions might be. Dr. Russ Roberts is an economist and the John and Jean Denault Research Fellow at Stanford University's Hoover Institution. He has taught at Stanford University, George Mason University, Washington University in St. Louis, UCLA, and the University of Rochester. Dr. Roberts received his education in economics from the University of North Carolina, Chapel Hill, and the University of Chicago. He specializes in communicating complex topics in understandable terms without diluting the concepts or the discussion. He is also committed to educational outreach through media that are accessible to everyone. In 2006, he launched the weekly EconTalk podcast, where he interviews distinguished scholars, noted authors, and global thought leaders on a variety of important topics. All of the past episodes of this online winning podcast are available free of charge online. Last year, there were 3.2 million downloads from the EconTalk archive. Dr. Roberts is also the author of 3 economics novels. Notice I said novels. I didn't say textbooks, including The Choice, named one of the best books of the year by Business Week. His most recent book is The Price of Everything, a novel on how emergent order affects our daily lives. Dr. Roberts is the co-creator of the Keynes-Hayek rap videos. They've been viewed over 7 million times on YouTube and subtitled in 11 languages. I am a big fan of Dr. Roberts' work, particularly the EconTalk podcast, and I am just delighted that he is visiting our campus today. Would you please join me in welcoming Dr. Russ Roberts? Dr. Roberts will lead the discussion this evening, and I invite him now to introduce the topic and the panel.
Today is March 3rd, 2014, and welcome to a special edition of EconTalk, recorded live at the College of Business Administration at the University of Alabama in Huntsville. I want to thank the Dean of the Business School, Karen St. John, and the university for hosting this event. Our topic for today is climate change, and I'll be moderating a conversation in front of a live audience between 2 scientists with different perspectives on the issue. Climate change reminds me a lot of macroeconomics. We have a complex system with many causal factors, and we're often interested in the impact of one key variable. In macro, it might be fiscal policy or monetary policy or a change in taxes. With the climate, we're interested in how temperature or rainfall or hurricanes respond to human activity, and in particular, increases in carbon dioxide in the atmosphere. With both the climate and the economy, there are experts on both sides of the issue who are highly confident they understand how these complex systems work. Everyday citizens, those of us who are not experts, we struggle with figuring out where the truth lies. How do we evaluate which experts are credible? Who can we trust? Is that the wrong model? Is it possible for anyone to figure out where the truth lies? And what I'm interested in discovering today is where there's agreement, where there's disagreement, and why does disagreement persist in this very important area of public policy and science. Now to introduce our guests. John Christy is Distinguished Professor and Director of the Earth System Science Center here at the University of Alabama in Huntsville. He's a Fellow of the American Meteorological Society, earning a special award for research, and he has received NASA's Medal of Exceptional Scientific Achievement for the satellite work he and Roy Spencer have done measuring temperature. John, welcome to EconTalk. Kerry Emanuel is the Cecil and Ida Green Professor of Atmospheric Science at the Massachusetts Institute of Technology. His specialty is hurricane physics with interests in cumulus convection and advanced methods of sampling the atmosphere for numerical weather prediction. He's the co-director of MIT's Lorenz Center, a climate think tank devoted to basic curiosity-driven climate research. His latest book is What We Know About Climate Change. Kerry, welcome to EconTalk.
Thank you.
We're going to start with each guest making a brief statement, 1 to 2 minutes, about what we know and don't know about the climate. To get us started, John Christy, go ahead.
Thank you, and it's a delight to welcome both of you here to the University of Alabama in Huntsville. Ultimately, the question before us tonight is a moral question, not a scientific question. Is it good to enhance and lengthen human life? Today and for the foreseeable future, the reliable energy that enhances human life and which is economically viable comes from burning carbon. That will continue no matter what our country decides to do. Does extra CO2 cause climate problems? The observations tell us not much is happening to the climate that hasn't happened before. Now, a fundamental aspect about the scientific method is that when we understand a system, we can predict its behavior. That has not happened for our climate system. It is true that we have an expensive climate modeling industry that shows scary changes, but they are unable to replicate the actual climate system today. In fact, 100% of the latest climate models overshoot the key target variable of climate change detection. And there is no model that has been rigorously validated for reliability. We are not bad people for burning carbon. Indeed, from my experience living in Africa, I can say with conviction that we are good people because of the immeasurable enhancement to human life that carbon now provides.
Kerry, Emanuel, what is your view of what we know and don't know?
Well, thank you for inviting me here. It's delightful to be with you all this evening. In the middle of the 19th century, the gifted Irish physicist John Tyndall made a remarkable discovery using a laboratory apparatus of his own devising. That is that all of the absorption of infrared radiation that takes place in our atmosphere is done by a tiny amount of gas that makes up less than 1% of the atmosphere. That was quite a shocking revelation at the time. And not long after that, the Swedish chemist Svante Arrhenius found out that the climate is heavily regulated by one of the greenhouse gases, carbon dioxide, whose mass represents 4/10,000ths of our atmosphere, a tiny trace, and calculated that without that 4/10,000ths part of our atmosphere that's carbon dioxide, the Earth would be a snowball. We wouldn't be here. We couldn't survive. This is not in dispute, this finding in the scientific community. It was not made with supercomputers. It was made with pencil and paper, and it can be replicated today. If that tiny amount of greenhouse gas is what's making our planet habitable, it would be no surprise that if we double or triple it, we're taking a risk with the climate system. And that's how it has to be viewed. It's a risk. So going forward, we're taking a risk, not with ourselves, not with me, I'm old enough that it doesn't matter, but with future generations. And a rational people deal with the risk rationally. And my whole program is to try to detribalize this debate. You know, it's not about there's going to be a climate catastrophe on the one side or nothing on the other. And it's also not about trying to do something about it. Will be an economic catastrophe on one side or won't have any effect on the other. That's not the way the world works. The world is more complex. We have a set of poorly quantified risks for action and a set of maybe as poorly quantified risks in taking action. That's the problem we have to deal with, and that's why I've come here tonight to talk to you about it.
So I want to start us off by talking about the idea of climate models. John, you said that the climate models have been poor predictors. I want to get your opinion on that, Kerry, in a second. But before we talk about the quality of these models, Kerry, I wonder if you could start us off by explaining how these models are actually constructed. So in economics, what we do, we have a lot of data, say, about a macroeconomic variable, GDP, or labor, the amount of employment, the number of hours. And we know it's a factor of a lot of different variables, so we try to use very statistical techniques, typically multiple regression analysis is the fancy term, to try to hold other things constant while one thing changes and look at the impact of that one thing. And the statistical techniques that can do that are pretty good. Then there's issues. Have you measured things correctly? Have you controlled accurately for these variables? Is it legitimate? Or is there correlation going in both directions, et cetera? Is that what we do in climate modeling, or is it a little bit different?
Well, let me just preface my answer to your important question by saying that a lot of what we know about the climate system was predicted long before there was such a thing as a climate model. It's a mistake to think that everything we know about climate or predictions about climate are based on complicated models. Having said that, we have built over the years a hierarchy of increasingly complex models. They really are some of the most complicated pieces of software that the human race has ever constructed. They had their origins in models that were built for a much more pedestrian but important purpose, which is weather forecasting. And they're very complex. In the case of weather forecasting, arguably you can test them twice a day and see how well they're doing. With climate, it's much more difficult to test them because we don't have that many climate states. But we do experiments that are much along the lines of what you had just described is done with economic models. We try to hold certain variables constant, like sunlight, and vary another external factor like carbon dioxide to see how the system responds.
But in the case of economics, what we typically do is we take, say, data up to the present, and then we say, based on the relationship between these variables in the past, here's what's going to happen in the future. Is that the same idea in climate modeling?
No, it isn't the same because there's a huge difference between climate modeling and economic modeling. We know the equations. You guys don't. Okay? So we actually know the equations we're trying to solve, and the problems come with actually trying to solve them. And arguably, our computers aren't nearly powerful enough to really solve them exactly, and they won't be for generations unless there's some unbelievable breakthrough in computation. So that philosophy is very different. We're actually trying to solve known equations for the most part.
Yeah, so in economics,
Yeah.
I don't want to miss a chance to get in my favorite joke at economics, which is, how do you know a macroeconomist? And the answer is because a macroeconomist uses decimal points, and that's clearly an illusion of precision in the case of macroeconomics, whereas here the issue isn't the precision of the underlying equations, it's how do the underlying equations interact. Is that a correct way to summarize
I think
what
that's
the issue
a
is?
fair way to summarize it, sure.
Let's talk also, and we're going to get into the implications of these models in a second. Before we do that, one more bit of foundation language is, John, I'd like to hear you talk about how we actually measure the raw variables we want to talk about, because John's done a lot of work on that here at the University of Alabama in Huntsville. And I think most of us who are not climate scientists tend to think, well, there's a thing called the temperature. But of course, the world's a big place. And the temperature, the thing we're trying to explain and measure, is not so straightforward. So talk a little bit about the level of complexity involved in that is.
Well, it's quite a bit, I think. Let me first of all say that we don't have a thermometer that can tell us how much warming is due to human effects and how much is due to Mother Nature. We just don't have a thermometer to do that. And so it comes down to a lot of times about opinion about how much is one way or the other. Now, to measure at least what the temperature is doing, the way Roy Spencer and I have done it is through the fact microwaves in the atmosphere, or from atmospheric oxygen, upwell and are captured by satellites, and the intensity of that radiation is proportional to the temperature of the atmosphere. That's fairly straightforward. When you talk about measuring the thermometers on the surface, it's a much more murky process because the thermometers come and they go, the instruments change, a lot of places aren't monitored. The setting around the thermometer changes with parking lots or farms or so on. So that's kind of a bit more of a complication there.
Kerry, is there any dispute about the underlying data to be explained? Is there how precise is that?
In science, there's always dispute about the underlying data. You never can get around, nor should you try to get around it. However, the surface temperature record for the last 80 years or so is pretty robust. So how do we know that? Well, we can take the analyses that are based on the observations and arbitrarily throw away about 70% of the data. Just throw it away, redo the analysis, and we see the same long-term trend. Of course, the little wiggles from year to year and decade to decade. It's a pretty robust record, but it is not by any means the sole piece of evidence observationally for the fact that the Earth is changing now. Yeah.
So let's get into that. We'll start with John. John, you just said in your opening remarks, and you've written recently in the Wall Street Journal, that climate models have consistently over-predicted the amount of warming, correct?
Yes, we looked at 102 of the latest simulations. That's all that we were able to download. And in every single case, we saw that the portion of the atmosphere that is most sensitive to greenhouse forcing, in the models at least, overpredicted by at least a factor of 2 what has actually happened in the world over the past 35 years. So we're not talking about just 10 or 15 years. This is over a third of a century that we can see these models are over-projecting what is actually happening on the planet.
Do you agree with that, Kerry?
Not particularly. I would say I'm actually share with John a inherent distrust of complicated models. I don't like them particularly. It's one of the necessary evils, and I want to get back to the point that we base projections, even projections, on a lot more than models. Yeah, it depends very much on where you look, when you look, and the time period over which you look. If you look at Svan Arrhenius' prediction about what would happen in 1897, he said that doubling CO2 would give rise to about a 4-degree centigrade change in temperature. 4. Today, with all of our supercomputer models, we estimate that doubling would result in a temperature increase of between 1.5 and 4.5 degrees C. That's not bad for the 19th century when you were doing things with paper and pencil. If you look at the temperature record and the natural logarithm of the CO2 content over 100 years, there's a spectacular correlation between the two. Is it perfect? No, because there is natural variability. There always will be, and it's poorly quantified. I don't think we understand it very well. I will say that, as predicted, most of the heat that you're putting into the system from excess greenhouse gases actually goes in the ocean, because it's much more massive and has a higher heat capacity. We haven't been able to measure the ocean nearly as well as the atmosphere until quite recently. But in the last few decades, it's very clear that the heat content of the ocean is going up. So we have lots of different, completely independent pieces of evidence, none of which, I would argue, and here I agree with John, is a smoking gun, but all of which together amounts to a very compelling case that the climate's changing and we're doing it.
You agree, John?
Not exactly, no. I'm not going to argue about the fact that the temperature has risen. Well, here's a news flash. The temperature has always risen and fallen in the Earth's history. It has been warmer than it is today. It's been cooler than it is today without the impact or the influence of mankind. And so I go back to that other point. We don't have a thermometer that can tell us this much is due to humans, this much is due to Mother Nature. And so someone can make the case that it's all due to human effects, or someone can say it's all due to Mother Nature, because we don't have a way to separate that.
Kerry, do you agree with that?
I can say from the models, though, that the hardcore evidence we have is, and anyone can repeat this, is that every single one of the models over-predicted what happened over the past 35 years.
I want to focus on 2 issues here. One is the over-prediction of the particular, the sophisticated models, not the back of the envelope. And 2, do you agree with his statement, which I know you don't, that we cannot disentangle any actual increase between human and natural causes?
Well, let me first say that, clearly the climate has always varied. And one of the spectacular successes of climate science is to begin to understand how it's varied in the past. I'm not going to get into it here. We pretty much understand the root cause of the great glacial cycles. There have been roughly 10 in the last 3 million years. So there is something about climate science. But the fact that it's always changing, right, is not mean that we shouldn't be concerned about the change that's going on now. I mean, saying that it's always changed in this context is rather like a defendant in a murder trial saying, yeah, well, people are always dying, right? It's true, but we're concerned about this change and what it pertains for the future. So I'm afraid I lost track of
the specific question I want you to challenge John's claim is that, well, there's been some warming, and we're going to, in a minute, I want to press each of you to talk about how much, because magnitudes matter a great deal, I think, particularly when you get to the policy implications. But there's been I think there is a real genuine consensus from people that the climate is warmer today than it was 40 years ago, say.
Yeah.
And then the crucial question is, how much warmer and why? John says we can't measure why it's warmer, dividing it between disentangling human versus natural causes. I don't think you agree with that.
I don't agree
So
with,
why?
I agree with that on a 10 or 15-year time scale. I don't agree with it on a 50-year time scale. The fact is that most of the changes we see in climate on these longer time scales are forced, and there are a variety of things that force it. It's not just greenhouse gases. There's solar variability. There's cooling of the planet demonstrably when volcanoes erupt. And there's cooling of the planet that's caused demonstrably, I think, by us through aerosols and things. The fact of the matter is that solar output, which has been measured very carefully for a few decades, has, if anything, been going down. This warming that we've seen in the last 40 years, I would say with 95% confidence, and 95% of my colleagues agree, has been caused by greenhouse gases going up. Now, is there a chance that John's right and it's not, or that, whether regardless of how John feels about it, it's not going? Yes, there is, okay? You know, this is what risk is. If you sit here and say, I need a complete guarantee that we're taking a risk before I do anything, you're not treating this problem of risk the same way you treat any other part of risk. If someone said to you, if I said to you, I'm going to let my toddler cross the street unless you can guarantee with 98% certainty that that toddler won't get run down, I'm not going to be very comforted, right? That's the problem we're dealing with. Can I prove absolutely in a court of law? Probably not, but to the satisfaction of 97% of my colleagues, yes.
John?
That 97% is a canard, I think. That is a very simple question about, do humans contribute to climate change is the root and meaning of that question, which I would agree with. So I'm in the 97%. Like I said, we can't tell why it is warming, but one of the tools that you can use to untangle this is a climate model. And so we can put CO2, extra CO2 in the model and see how it warms. Well, using the same amount of CO2 putting in the model that is actually in the real world turns out to produce, on average, models that are 3 times warmer than what has actually happened. So my claim is, whatever is happening in the world, at least the climate models are overdoing it. It's very clear there. There's no question about that, because that's what the evidence and the numbers show. And so I don't see the real prominent things that probably are happening with negative feedbacks and internal variability. Just the way the internal physics of the thing works can lead to rises and falls in temperature. And so they have happened in the past, and it's hard to convict carbon dioxide of committing a crime if he can look back and say, but this has happened before and I wasn't there.
What's your answer to that, Kerry?
Well, I think it's relatively easy, and in fact, von Arrhenius did it in 1897 without big supercomputers. My students do it after taking a couple of semesters with models they build themselves. I don't think it's that difficult, but I would agree that internal random variability is there, and the climate would change even if all the forcing agents I've talked about before were constant. We're confident of that. We're not terribly confident that we know this noise quantitatively. For example, it might be that if it weren't for carbon dioxide increasing, that the climate of the Earth would have cooled over the last 15 years. We don't know that that's not true. These fluctuations occur on top of the forcing. So it's a little bit like, you know, here in Alabama, you can have a day at the end of April which is colder than a day at the beginning of April, and you wouldn't conclude from that that summer isn't coming. You have weather superimposed upon the seasonal cycle. I will say that climate models have been wrong in a lot of different regards, and there John and I agree. Their predictions aren't particularly good, but it's not one-sided. For example, no climate model predicted the demise of summertime Arctic sea ice at the rate it's actually occurring. It's going much faster than any model predicted. And I'm in the field of hurricanes, and I actually made predictions back in the 80s about how fast hurricanes would respond to climate change, and at least in the Atlantic, they've been responding much faster than I can account for. And no, I don't know why, okay? So these models aren't particularly good, but all of the evidence points to a pretty compelling picture of risk here.
Okay, I'm going to come back to the economics point, and we just passed the 5-year anniversary of the American Reinvestment and Recovery Act, the so-called stimulus package. And proponents of the stimulus package would tell you that it worked, and they'll point to historical examples where stimulus worked, but they won't point to the examples where it didn't work. and they can't predict the impact. They did not accurately predict the impact on, say, unemployment rate, which they grossly underestimated the impact on unemployment. The question is, what do you do about that? You concede that the models are inaccurate, but you don't concede that there is inaccurate in only one direction. Would that be a correct way to summarize that? And you want to say anything else in response to that?
I would just say yes, none of the models predicted that the Antarctic sea ice would increase either.
That's right. Yeah.
That Arctic one needs to be balanced by that. But in terms of this fundamental parameter of the bulk atmospheric temperature, every single model went the wrong direction.
Is that accurate? Do you agree with that?
Not entirely. I'll tell you why. Because these models are not just run once. They're run many times to try to account for their own internal random variability. And you can find 15, 20, 25-year stretches in all of these projections where the temperature not only flattens out, but actually goes down a little bit. So if you take the ensemble mean, then it's correct that the last 30 years, the models have over-predicted the temperature change. I might add that 30 years before that, they under-predicted it. And this is what happens when you superimpose natural variability on force variability.
So in your book, you suggest that over the next 100 years, and I'm addressing Kerry now, for those of you listening at home who can't see us up here, and who can't tell the voices apart maybe as well as you might, you suggest that in the next 100 years, quote, if nothing changes, and of course it's hard to, you didn't really mean that literally if you said that. It meant if we don't do anything radical to slow down the accumulation of carbon dioxide in the atmosphere, that the temperature would grow it would grow in a range of 2.5 to 9 degrees Fahrenheit. So the low estimate of the impact would be 2.5 degrees. The high estimate would be 9 degrees. How confident are you of that range? We'll talk about the implications of it in a sec, but how confident are you of that?
Well, if you choose the range large enough, it's easy to be confident.
You get more confident. You get more confident. But that's that's a large range, but it starts with the lower end is pretty high. So that's why it's
Fahrenheit? Is this
Fahrenheit.
Fahrenheit. This is something that any serious climate scientist, and I think the two of us on this stage represent this in this respect, would immediately tell you is that we're very uncertain about these projections. Nobody pretends to be certain about it. There just isn't much certainty in that. To say it's between 2.5 and 9 degrees for a doubling or more of CO2 Fahrenheit, it's to confess that we don't know a lot, all right? And so what we're dealing with is a probability curve, okay? In the near end, if it's 2.5 degrees, we don't have to worry very much, I would argue. I don't think very many of my colleagues would suggest we do. If it's in the middle of the range, there'll be problems. Probably we'll adapt to them. If it's up at the higher end, that could be catastrophic. And the question for me is, do we do nothing to avoid even a small risk of catastrophe for our grandchildren? To me, that's the moral question.
We're going to come to that in a second, maybe a little more than a second. Toward the end, I want to talk about what ought to be done, if anything, to cope with this. But I want to get John Christy's reaction to the 2.5 to 9. It's a modest claim on the surface because it's a large range. It's like when the CBO says things about the Congressional Budget Office about the impact on employment. They're very often vague, which gives it an unscientific air. It does raise the question of the precision of the estimate. But again, it's a large range, and you'd think that would engender confidence. Does it engender confidence in you, Chuck?
Well, I would go with the very low end part of that range. And we have, 35 years period that has a couple of volcanoes that help tilt the trend a little bit higher, but it is rising at about 2.5 Fahrenheit per century right now. So that's some evidence that that's about the rate it wants to go.
He can't make you more nervous for your grandchildren?
No, I love my grandchildren. I think I'm more nervous about, something the government might do that would harm them more than anything the climate might do.
Okay, that's a cynical approach. It's a cynical remark that I am of course sympathetic to, but we want to put my sympathies to the side until we get to the discussion of policy. I want to bring up another issue that, in terms of just the record and what we know and don't know. what is your feeling, Kerry, about the apparent, and you can challenge the claim if you'd like, the apparent pause in temperature rise over the last 15 years? Again, as a crude, empirical, I'm a mere social scientist, yes, I confess. When I look at the raw numbers of the temperature anomaly over the last 15 years, it looks awfully flat to me. Is that correct? And how do you, given that the rise in CO2 over that period has been the same as before, it's been rather dramatic, how do you explain that, and what's your position on that?
Well, I would be dishonest if I told you I understood that. First of all, just to answer your straightforward question, yes, the temperature, global mean temperature, has been pretty flat for 15 years. It was also pretty flat from about 1950 to into the 1970s or so. So it's not the first time it's flattened out. And I don't think the community of scientists is very sure about is whether we're seeing a manifestation of internal variability, natural oscillations that happen to be working against the radiatively forced signal at the moment, or whether there's something about the radiative forcing that we haven't understood. For example, my colleague at MIT, Susan Solomon, just last week published a paper, I think it was in Science, I don't know if you saw it, suggesting that the fact that we've had a large number of relatively mild volcanic eruptions in the last 10 or 15 years may have put enough aerosol collectively into the atmosphere to affect the temperature. Now, I haven't had a chance to digest that. I think the scientific community does have to get on top of this, and in fact, all the other periods of reduced and enhanced warming in the past.
Does the pause give you pause? You were confident that there is a small chance of a large rise based on the rough science and some of the models. Does it cause you to be a little more conservative?
Well, no, not really. I mean, I think that range was generous enough that I would stick with it until, maybe if we had 30 years of a pause, that would give me pause. But, you know, what will
we'll be back in 2029, perhaps.
What will we all be saying if the next 15 years is rising at twice the rate the models predicted? Will we be trying to revise our estimates? I would have to say that I think I probably wouldn't revise my estimate upward either in response to that. There's a certain amount of natural variability that goes on.
What are your thoughts on the so-called pause, John?
I have no idea why it happened, but my thoughts are back to what I said in the introduction. When we understand a system in a scientific way, we can predict its behavior. I know of no one who predicted a flat temperature trend for the past 15, 16, 17 years. We were all under the belief, me included, that CO2 forcing would cause even more warming, and yet it did not happen.
However, we do see, and I noticed this elsewhere than on this platform, that people who are worried about global warming and climate change point out there have been many plateaus in the past, that the underlying trend is what matters. Small short-term variability of, again, it's 15 years is one person's eon and one person's blink, another person's blink. You're suggesting it's closer to an eon. Kerry thinks it's a blink. Can't really make any conclusion from it. Past times we've had plateaus. Is that just the difference here? Just a question
Well, remember
whether it's...
when we talk about 120, 30 years, we're starting at one of the coldest periods in the Earth's history in the last 10,000 years. So the fact it's warming at all could be completely due to natural variations. I happen to think the extra carbon dioxide, there's no way you can say it is not a forcing mechanism. It is doing something. And it turns out, from what I gather and from what I can understand, is that there are ways that the Earth system itself naturally feeds back in a negative way so that that heat energy is not being stored like a climate model stores it. And so therefore the temperature is rising much more slowly overall.
Kerry, can you convince him? Can you try to take a shot? Because here's what I think. You can't argue with this basic point, because you've conceded it, that, of course, in any 1 year, any 5 years, maybe 15 years, things happen we don't fully understand. The world's a complicated place. But the underlying science, which you went back to 1897, which seems very convincing, why can't John Christy see that this large increase in carbon dioxide accumulation is inevitably going to cause significant warming? Why do you think you can't convince him of that?
Well, because I'm a climate scientist and not a psychiatrist, I guess. It's true.
It's a cheap shot, Kerry. Go ahead. But an amusing one. The crowd really liked it. Go ahead.
I could have said something about an economist.
I'd join you on most of that. That wouldn't help.
But you really do, I think, to look at, when you look at the Earth's history, the response to forcing is at long time scales. I think you really do have to look at the 100-year time scale. That's very hard for us. We're much more interested in what's happening today and tomorrow and very early on. When you look at the very long term, let's say not even that long by geological standards, 3 million year record of climate on the Earth, and you see the spectacular fluctuations of climate, yes, and they were natural, and yes, in the case of glacial, the carbon dioxide content itself fluctuated. In fact, most climate scientists believe that the reason the tropics cooled and warmed was because of changes in CO2. What you see when you look at that record is the last 7,000 years, up to about 100 years ago, was remarkably stable. The sea level was remarkably stable. The climate was remarkably stable. We were very blessed to generate civilization in that 7,000 years, okay? And yes, if we didn't do anything at all, the orbital forcing suggests that we would be slowly cooling, as we in fact were up until about 100 years ago. I agree with that. And we would continue to cool until maybe in 10 or 20,000 years, that's really a long time away, we would plummet and probably will plummet into another ice age. This thing is short, that we're doing now is short by geological standards, but still fairly long on the human time scale. And I can't convince myself, as much as I would like to, that we aren't running a risk. I think we're running enough of a risk with our grandchildren that we should pay attention to that.
John?
Was I supposed to be convinced by that?
I don't know. Yeah, you could mention psychiatrists if you want, or anything else you think
No,
would be.
I just go back to the hard numbers of the data. We just do not see these kinds of changes that are dramatic, that were predicted. They're not happening. And so I just am rooted in what's really happening in the planet. That's why.
Well, let's move on to a different area, which is sometimes comes, as far as I can see, goes under the name of extreme climate events. This would be hurricanes, droughts, famines, et cetera. Kerry, your specialty is hurricanes. Have hurricanes and other extreme events gotten worse over the last 40 or 50 years, and can we attribute that to human activity?
I'm sorry to have to give a nuanced answer. In the Atlantic,
I like nuance, don't worry.
demonstrably, hurricane power has increased over the last 30 years by a big factor, a factor of 2, okay? I don't profess to understand that. It's gone up hand in hand with the tropical Atlantic surface temperature in the summertime. That's a tiny piece of the globe. And maybe some of that's global warming. I don't honestly know. I don't want to try to give you the illusion that I understand this. When you look globally, the problem there is a problem with data. The data is very poor outside the Atlantic. In the Atlantic, we fly airplanes. I've done that. We fly airplanes into hurricanes. But we don't do that anywhere else in the world. 90% of the world's hurricanes occur outside the Atlantic. And so we're forced to rely on data which is not particularly suitable for this. There is some indication of an upward trend in the most intense hurricanes, but I wouldn't want to put my money on that. No.
Did you say you've flown airplanes into hurricanes?
Yeah.
What was that like?
Better than some flights I've had on Delta Airlines recently. Seriously, they're not. It's not as bad as you might think.
Okay, I was going to say, as someone who doesn't want to take a lot of risks, that would make me a little bit nervous. But sounds like it was probably a pretty exhilarating experience.
Everybody should see the eye of a hurricane. And so when I retire, I'm going to start a hurricane safari operation. Take paying customers in.
That'd be awesome. John, what do you think about hurricanes?
Dr. Emanuel's the expert on that, and I think he gave a terrific answer there. I look at other kinds of climate variables that are more readily available to us in terms of longer data sets, and those are things like droughts and floods and so on. And we are nowhere near the kinds of extremes that have occurred in the past 1,000 years in this country for sure, where we have had mega droughts. These are 100-year kind of droughts out west, and the periods of dryness, and in fact the temperature here in Alabama has actually declined in the past 130 years. So when you look at those kind of extreme events, you don't see any change really.
Do you think there's hope of modeling hurricanes, more precisely?
That's not a question I can answer. I always hope we can get better tracks because we are exposed on our Gulf Coast, and it would be a terrific advancement to have it.
Are we getting better at it?
Over the last 40 or 50 years, we've gotten substantially better at forecasting hurricane tracks, really demonstrably better. Not much improvement at all in hurricane intensity.
Yeah, the tracking thing, you know, they have a band of uncertainty around it, and I remember as a kid, they were always off, and now they're really pretty good. You know, I'd always say, when I look at the picture, I'd say, well, who knows, but they're pretty reliable now. Seems that way. Let's talk about another thing people care a lot about, you mentioned briefly, which is sea level and Arctic ice. It's an issue that came up in a recent EconTalk episode with Judith Kerry. What's going on with ice in the north and the south? What do we know about it? How much uncertainty do we have about it? Its an impact on sea level. Kerry, you go first.
So sea level is going up, and apparently at an accelerating rate.
Can I ask you before you
yeah,
go on, how do
okay.
we measure that?
Well,
There's the seas in a lot of places,
Okay.
so
That's right. That's right. So before the satellite era, it was measured with tide gauges, and there's a real sampling problem with that. By the way, most people think the sea level rises uniformly around the globe. It doesn't. You can actually find places where it's going down, just like temperature. And that's because it's affected by wind and things. In the satellite era, we've been able to measure the absolute altitude of the sea level globally with absolutely stunning accuracy. The magicians at NASA somehow figured out how to do this. And there's no question that it's going up globally now with those measurements. The ice is more complicated. First of all, sea ice, which we see a lot of changes, doesn't affect sea level. When it melts, it doesn't change sea level. Summertime.
at all, in general?
No, the sea ice doesn't change
That's
sea
not an
level.
issue.
No, in fact, if you don't believe me, right after this talk, go and mix yourself a nice scotch on the rocks. I highly recommend it, and watch the ice melt. Tell me what happens to the scotch.
Simple
or if you're
science.
a teetotaler, you can use Coke. That's okay. That's allowed. Anyway,
People don't talk about it that way, though.
no,
They
it's
talk a lot about the ice melting affecting
Yeah.
the sea level. Is that
well.
not
So
true?
land ice, when that melts,
Oh.
it does affect me. So when ice melt that's sitting on land, like Greenland or Antarctica, melts, that affects sea level. It melts, the
Okay.
sea level goes up.
All
So
right.
the sea ice doesn't really change things. And Arctic sea ice in summertime has been in decline since we've been able to measure it, which isn't terribly long. Antarctica is mixed, but in general, actual sea ice is increasing around Antarctica, not decreasing. Mountain glaciers, which are another form of ice, are almost all of them in retreat now, and we see big changes historically in glaciers. It's much harder to measure what's important for sea level with the big ice sheets in Greenland and Antarctica. And we're getting better and better at measuring those, but I think it's a little bit too soon to say what's happening to them in bulk. The weight of the evidence is that they're losing mass, but they're certainly not losing mass everywhere.
And what kind of magnitudes of sea level change do you think we're talking about here?
Well, this is the best estimates from the last IPCC report are on the order of a meter or so, 3 feet by the end of the century. But everybody who's in that business says there's much more uncertainty about that than anything else. And one of the problems is that we don't actually understand the physics very well. You'd think we would by now. If I had written a book called What We Don't Know About Climate Science, it would have been an encyclopedia.
Longer book, yes, no
But
doubt.
we don't really understand the physics in which ice slides off of big continents like Greenland. It's not just melting and the water trickling into the sea. There's actually glaciers that flow off the ice sheets and calve into icebergs. That's what did the Titanic in the ocean. And we don't know whether that will accelerate. Here's what we can say, is that there were various times in the geological past during previous interglacial periods where apparently most of the Greenland ice sheet was gone, not all of it. If you did melt it all somehow, and it'd probably take a long time to do that, you're talking about 7 meters of sea level rise, 25 feet or so. It's a big number. And Antarctica, if you melted that, I can't remember the exact number, but it's much more. It's 50 meters or something like that. But that's an awful lot of ice, and everybody I know in the field thinks it would take an awfully long time to do that.
The implication is that small or potentially large parts of currently inhabited parts of the world would be underwater if it...
So if we go into an extreme...
I'm sorry, I just want to say,
Yeah,
I've seen
yeah.
these, you may have seen these where Florida, drops off the face of the earth and becomes an underground island. And my attitude on that is partially, well, if it happened overnight, it'd be really bad. If it happened over 150 years, not so bad. If it happened over 10 years, much harder to deal with. Might not be our best thing. But what are your thoughts?
Well, the time scale is everything, and it certainly won't happen. We don't think it will happen in 10 years. But here's some food for thought. I think, and I'm now speaking a little bit more philosophically, that historically science and scientists have been very conservative in their estimates of risk. We didn't predict that there could be a magnitude 9 earthquake off of Japan that caused that huge tsunami. The largest estimates were 8.3, which is way lower, actually. There are a lot of things that we haven't predicted. What we do know from the ice core records is that in the past, particularly during cold periods, the Earth was capable of rather sudden changes, flips, if you will, in the climate, at least locally, and we don't understand those flips. So, what keeps us awake at night are the risks that we're missing, okay? And, we don't think the Greenland ice is going to go very fast, but there are a few models on it that say once it gets going, it's really going to go. Nobody attaches a lot of importance to that, and we put a very low probability on that, but we're frightened by what we don't know about that problem.
John, talk about your thoughts on ice and sea level.
Well, sea level is rising, and it will continue to rise because there is more land ice to melt. Go back to the last interglacial about 130,000 years ago. We find that sea level reached 6 meters higher than it is today. So that should go on about 1 inch per decade just on that. Remember that the out west in the Rocky Mountains and so on, those glaciers only appeared between a period of 3,700 and 1,900 years ago. So they are relatively new in the sense of our most recent climate. When I advise people about sea level, I say it's going to go up about 1 inch per decade. And if you're on the Gulf Coast, that's not your problem. It's the 15 feet in 6 hours when the next hurricane comes. That's your problem.
For sure.
And so that's the attack, and that's the vulnerability you really have there at the coast.
So you don't think there's a social or civilization issue that over the next 100 years we're going to lose some important things?
Well, it would happen very slowly when people are building infrastructure on the coast, and I have to do some kind of reports for those. I tell them, look, if you're going to be there 100 years, plan for 1 meter sea level rise. And if you build your infrastructure for that much, I think you're okay, but the hurricanes are what's going to hit you.
But do you think that we can do something about that meter? In other words, can public policy or human behavioral changes reduce the threat of the meter increase?
No, I presented evidence in federal court before Congress and so on that the legislative actions being planned and so on just will have no impact on that.
Do you agree with that, Kerry?
I don't think it will have a direct impact, but I think it could have a pretty big indirect impact. It's like all movements that go on. It starts small, and it starts with something doable, whose direct effect is probably not measurable. So in that sense, I agree with it. But you have to start somewhere. You can't start with solving the whole problem in one day. That doesn't work. You have to start somewhere. And I suppose at some point we'll talk about solutions to that. But
In about a minute, yeah.
yeah.
But I want to go back to John's claim, because the way I understood John's claim is that the rise in sea level over the last century and the expected rise over the next century is overwhelmingly driven by a large trend that has nothing to do with human change, human activity, which is the recession of the ice age and glaciers that's irrelevant, where carbon dioxide has virtually nothing to do with it.
Well, right now, the carbon dioxide influence hasn't had a whole lot of time to build up. It's only been around a few decades, really. And it is these big blocks of ice, and they take a lot of effort to melt. And so it takes thousands of years for these things to melt. Is carbon dioxide adding to that? I think so. I think it is adding a little more. That's why I said 1 inch per decade instead of the 3/4 of an inch for last century that we experienced.
One of the greatest things in the world that I didn't know about until recently is that until refrigeration, people made money carving out large blocks of ice, putting them in the holds of ships, and taking them to very hot places where they could have a cold drink, which now is not a viable economic enterprise because of refrigeration, but it does take a long time for a big piece of ice to melt, which is rather remarkable. Let's talk about policy implications of this conversation. I'll try to summarize it. Maybe there's nothing more to say, because it may be that reasonable people can disagree on this. The way I understand, Kerry, your view is that there's a small chance of a really horrific action, and therefore we should act. Again, Robert Pindyke in a recent EconTalk episode, he's an economist, that's his assessment of the risk that's involved. This is not really it's partly a scientific question, but at some point it becomes a philosophical question, and John Christy, you called it a moral question. But it's a small chance of a horrific risk. We should try to do something about it. It sounds to me, John Christy, that your view is that, well, it'd be great if there was something we could do about it that was likely to work. You don't think the risk is very high, and you think the risk of the solution is likely to be worse. So, John and Christy, I'll let you go first. Does that summarize your view of the difference between the two of you?
Somewhat is that the risk of something bad happening by making energy expensive is real. People will suffer if energy prices go up. We already know that. There's just no question about that. And as I said, living in Africa, I know what energy poverty does. It kills people. And so anything we can do to allow energy to expand into those areas that do not have it is going to enhance human life and welfare. So solutions to, if you're really concerned about carbon dioxide, then how can you create energy that is affordable? It's the only kind that works in an economy. What choices are out there? And the big one that can answer the question is actually nuclear power. And we're sitting right here between a couple of big power plants, actually. It's difficult. It's a bet the company move right now for the few that are trying to build nuclear power. And that's probably got to change.
Kerry?
Well, I actually agree with that. I think that, it's a mistake to do anything that increases world poverty. And the history of this is very clear. Economic gains, particularly in developing countries, are largely very strongly tied to the consumption of energy. Yeah. So we have to be clever about how we attack this risk. And I'm not of the camp that says we should just go cold turkey on fossil fuels. We can't do that. Nobody in their right mind would suggest we do that. But we should try to approach this risk as intelligent people by exploring all kinds of alternatives. The experts I talk to, and I'm certainly not one, say it's a question of doing a lot of little things that amount to a big thing, like building more energy efficient buildings. Even in developing countries, it actually ends up saving people money because they're not consuming as much energy. Energy still costs something. Migrating away where it's practical from fossil fuels toward renewables. So there are some parts of the world, including Africa, where it actually makes sense to have a supplemental supply. Can't do everything with solar power or maybe wind. I'm a big proponent. I get into lots of trouble with my colleagues over this, but like John, I'm a big proponent of nuclear energy. I'm so tired of being told we can't do it. France went from almost no nuclear to 80% nuclear in 15 years. Are you seriously telling me that the United States cannot do what France did? I don't think so. There's one other piece of technology which would allow us to burn at least natural gas as much as we want to, if we could only get there, which is to capture the carbon from the atmosphere and sequester it. And I think it makes a lot of sense to put some money, not to jeopardize the economy, but some research and development money into trying to develop this technology to the point where it might someday make economic sense to do that. We're not that far from being able to do it even today. So these are sensible things. We don't have to bet the farm. We just do sensible things.
Do you think those sensible things work? Do you think geoengineering is feasible or will be feasible that would offset some of the human impact?
Okay, geoengineering now is a different kind of question. That's where you want to do something explicit to stop whatever climate change and gear it towards something you think you can. I think it is frightening to me to think of geoengineering. Because if we cannot predict the system now, how can we know what we're going to do if we try to geoengineer something, like put up a bunch of panels that reflect sunlight or aerosols in the stratosphere that reflect sunlight? Those are scary options to me because we do not know what might ultimately happen as a result of something like that.
Seems like a good time to invoke my favorite quote of F.A. Hayek. The curious task of economics is to illustrate, to demonstrate to men how little they really know about what they imagine they can design, which would be what you're worried about. Do you agree with that concern?
Yeah, very much so. I agree completely with John on this point. I think it's a big risk to do this kind of what solar radiation management, sort of geoengineering. The only thing that I will say is that the technology to do that today not only exists, but it's cheap. And the reason that makes me nervous is that it's not just a question of, for example, the United States deciding whether or not to do it. We decide unilaterally not to do it. Some small nation state somewhere, or even a very wealthy individual, could unilaterally do it. And that they might be tempted to do if some things go wrong. So we better understand this. But I don't think we should do it unless we're in really dire straits.
Any other comments on that, John?
No, I think that's it.
Okay. Well, I feel bad. We're getting short on time, and I want to ask some sociological questions. I just want to mention that I did want to talk about the tropical hotspot. I don't know if anyone wants to jump in on that before we move on. Anybody? Either of you? Okay.
That's what basically we covered when we were talking about the temperature and the models.
That's right.
So that's been done.
I know I have some listeners who are worried about it, but I apologize we didn't get into more detail. I want to talk about what we might call the sociology of this debate, which I find very frustrating. Whenever I mention climate change on this program, I get very angry emails from people who tell me I don't know what I'm talking about or that I'm dangerous. The thing that fascinates me is that my guess is that most of the people in this room have a very strong feeling about climate change, one way or the other, and yet none of you are climate scientists. I have a pretty strong feeling about that I don't have a strong feeling about it, which is maybe some of you are in that group as well, but most people have a horse. Most of my horse is agnosticism, but I have a little bit of John Christy's worry about policy interventions, but I'm not a scientist. And just like in economics, many people are not macroeconomists, have very strong feelings about whether stimulus should be tried, what monetary policy should be. And I find it fascinating how angry we get over that. So I want to close our last few minutes here and talk about the nature of that debate. And I want to start by asking both of you if either of you are ever embarrassed by people who are roughly on your side of the discussion, without naming names, who embarrasses you, but do you find it sometimes awkward to see who's on your side? I'll let Kerry Emanuel go first.
Absolutely, yes. I'm continuously embarrassed by people that are supposed to be on. But I don't consider it a side. I mean, it is very tribal. You're absolutely right. It's become
Tribal's
very
the right
tribal.
word.
It's
Yeah.
tribal. You're in this camp or you're in that camp. The bad guys are the good guys. The black hats, the white hats. It shouldn't be like that. This is a big, big issue, and it's not clear cut. If I knew how to defuse that, I'd do it right away, but I don't know how to do that. And yes, there are plenty of people on my side who are taking very extreme positions that cannot be defended scientifically.
John Christy.
Yes, the short answer is absolutely yes again. Climate science is a murky science. It's not a laboratory science. And unfortunately, we end up following arguments from authority or people who have high-sounding titles rather than trying to get into the difficulties of this nonlinear chaotic system that we really don't understand. And so people find more comfort in agreeing with an authority than trying to untangle the difficult situation we have.
A lot of people, again, this happens in economics, they pick an economist who's their hero, and that economist has a blog, and you go to the comments of the blog, and it's always unrelenting praise or hatred, and some economists purge hateful comments from their blogs, so all you see is love, and how great they are, and how smart they are, and how wise they are, and yet give it to them and tell them, and why is everybody else so stupid and evil and obnoxious and jerks? And it's very depressing to me because it never appears to cross their mind that someone with a different viewpoint might have an argument. It might not be right, but they probably have an argument. And when that person makes a claim against another economist, the crowd goes, yeah, you showed him, never imagining that economist usually has something to say. And I think, well, part of what we've tried to do tonight is to show that usually the other side has a response. Might not be right, but it's a response. It's a thoughtful response, even conceivably. As we finish talking about embarrassment, though, and shame, what might we do? What might we do? What could you imagine? And maybe the answer is nothing, but what might we do to make this debate less polarized, less angry? One of the things I find fascinating, how hard it is to criticize your own side even when you are ashamed of them, right? So I have plenty of economists who share my policy views who I don't like, and I do find it hard to blog against them. It's difficult, right? Because for 100 reasons, tribal reasons and emotional reasons and worries, but it's liberating when you do so. So it's a very healthy thing, I think, when we can criticize people who are roughly on our side. But John, do you think John Christy, is there anything we could do to make this debate a little more civilized?
Something that I've seen that helps make it more civilized is the simple admission, I don't know.
Yeah.
And when a question comes, and Kerry was very brave at points on his talk to say that as well as.
I heard it a few times.
Yes, to say we don't know is about the most honest way to start to diffuse that debate and get into what we need to know.
I think one other tactic, I mean, I'd dearly like to depolarize this and just get people talking, but I think we would be more productive if we argued about how to mitigate the risk. You can have all kinds of different opinions about the level of the risk. That's fine. But we should be arguing about, do we try to do some nuclear power? Do we do carbon sequestration? What do we do? We could make an argument that we should be doing this stuff if for no other reason than to sell it to other countries that take climate change seriously. So I think if we could, if not depolarize things, get the two teams to play on a different playing field where we argue in hopefully sensible ways about rational things we can do to try to reduce the risk going forward, we'd be all happier and in better shape.
So to close, I want you to give us some advice for those of us who are not climate scientists. So in preparation for this conversation, I read your book, Kerry, Emanuel. I read your congressional testimony, John Christy. I read your congressional testimony, Kerry, Emanuel. I read some blogs that think very little of both of you. And these are blogs that are very popular, very popular. And so those blogs that are out there, and just ask for a show of hands, how many people here read with some regularity a blog on climate science? Raise your hand. So a very small group. And yet everyone here, and we've got about 350 people here in the room, and I saw about 4 hands go up. So most of you don't do that. You're here presumably because you want to learn more about climate change. I'm curious whether either of my guests think that reading blogs is a good idea. And if it's not a good idea, what would you recommend for a thoughtful citizen who wants to become more educated about this issue? My advice usually on economics is, I find there's a lot of value to reading blogs, but you better read a blog on each side of the debate, maybe more than one, if you want to avoid being just a cherry-picking confirmation bias, patting yourself on the back person, which is a human impulse, but probably not the best role for a good citizen. So, Kerry, Emanuel, what would you recommend to the average person who wants to get more educated?
Well, I would not recommend, and I would not recommend out of concern for your health, if it's anything parallel mine, that you read blogs about climate science. And I think it is, I think a lot of people who do are unfortunately seeking confirmation bias. I think you ought to treat the overall community of climate scientists on this issue, most of whom will freely confess, as John and I have to you today, that there's a whole lot of uncertainty about this. The same way you might treat the medical profession, especially if you had some kind of disorder that the doctors were not agreed about. You'd want to get a spectrum of opinions. You don't have to believe that doctors are individually perfect. We know that they're not, and most of them don't say, well, there are some doctors who do claim to be perfect. They're not like climate scientists in that respect. You get a spectrum of, if all you're interested in is, what's going to happen in the future, I think you can do no better than to get a spectrum of opinions from experts. That's my personal point of view. But if you're interested in the science, if you're really sort of interested in the science, and it's a fascinating field, even if we didn't have any climate change at all today, man-made climate change is a really, really interesting field, and it's a wonderful intellectual challenge. There are a lot of resources out there that have nothing to do with bias. I would say there are a lot of good books about climate, just the physics of climate, and I'll be very self-serving to say I just started an edX course on climate science, which is just about climate physics and chemistry and biogeochemistry and so forth. There are a lot of resources out there, and you'd find it a very, very interesting experience if you're interested in science.
John Christy?
I think one of the places I find good information from all directions is in congressional testimony from hearings of scientists, not of the advocates, not of the administrative appointees, but of the scientists themselves, because they know they're going on the record. And so they're going to hedge their understanding and be a little bit more careful about everything they say. So that's one place I think I would go.
My guests today have been John Christy and Kerry Emanuel. Gentlemen, thanks for being part of EconTalk, and thank you to Karen St. John and the College of Business Administration here at the University of Alabama in Huntsville. Please, a round of applause for our guests.
Thank you.
I appreciate all of you coming, and what I would like to do now is take just a minute to give each one of our guests a plaque that we have. If you could bear with me for just a few minutes while we do that. This is for you.
Oh, thank you very much.
Wonderful. Thank you.
Appreciate
very,
it. It's a
very
great pleasure. Thank you.
Okay, thank you, Chairman.
And last but not least, our host, Russ. I hope that you feel you have been engaged and informed. I was very, very pleased with this. It accomplished exactly what we said we wanted to accomplish. I invite you to join us for a reception following this event. Our panelists will be available at the reception to answer any questions that you might have. I also want to comment, in case you wonder what is going on up at the front of this room, we are standing on the hull of what will be a ship for a play that will open here March 12th. So I want to thank the theater department for coming in and cleaning up what was their construction site this morning to allow us an opportunity to come in and host our program. Special thanks also to Violet Edwards and Gabrielle Cromartie for their extraordinary work today to get things in shape under some time pressure.
Karen,
Yes.
Can I just add, there will be, if all goes well, a video of this event up on YouTube,
Yes.
and it will be up at econtalk.org with the other episodes either a week from today or 2 weeks from today. So if you want to listen or share it with friends, it'll be available soon.
Absolutely.
Thanks so much.
We will send an email out to everyone who RSVP'd, giving them the details when it is up and ready to go. So please join us in the reception, and let's give one more round of applause.
Well, good.
Kerry,
Good going. Cheers.